less than 10 seconds.
Rachel, there has been a visitor that has visited us from the outer reaches of the solar system that has captured lots of people's imaginations. I think we should probably start off talking about Comet NEOWISE. Have you gone out and watched it?
I have, yeah. I went last weekend and saw it with my very own eyes.
So yeah, and I actually went out on Monday and Tuesday as well, and I was really amazed. And I'll just sort of like share my experience, and I would love to hear your experience as well, because I made a couple of mistakes, and I think like that's something perhaps a lot of people out there, may experience as well. Because I went down to Kitts Beach to go and watch it. I was there, just after sunset. So sunset was like maybe like 9:15 p.m. or so. So I was there like 9:30-ish. But of course, it doesn't get dark in the west, which is where the comet is, for another hour. So I was out there for a while waiting for it to get dark, even though if I looked up and like turned around to the back towards the east, you could start to see stars and they were starting to appear, but over towards the west where the comet was, still wasn't dark yet. So really until like 10:30-ish, I really start to see it. What was your experience like?
So I actually went early in the morning. So I went
Right.
between 3 and 4 a.m., woke up in the middle of the night and saw it with my own eyes. So I thought it was kind of cool because I actually used my peripheral vision to see it because it was quite faint. So
Yeah.
I didn't look directly at the comet, but I looked a little bit to the right of it and used my sensitive rod cells in my eyes to be able to pick it up. And I actually was able to use the long exposure setting on my phone camera to
Okay.
capture a picture of the comet. So even with just your phone, I was able to get a picture of it.
Yeah, no, I was really amazed. I was with a couple of friends that were amateur astrophotographers, and looking at it again with your own eyes, using that averted vision, but then looking at their screen as they were taking the picture and just seeing that tail really come to life was really fascinating. So the comet is still up there, and for people not only here in Vancouver and British Columbia, but all across Canada, over into Europe, we can see the comet at least, hopefully, maybe for another week. So Rachel, maybe you want to share with us maybe where people should be looking.
For sure. So to do that, I'll actually share my screen and show you a very useful website that I love to use, and that's called Time and Date. And I love it because it shows us the nighttime sky, what you can see on any given night or even during the daytime, and you can put in your location. So I've put in Vancouver, and I've clicked on the best time to view Comet NEOWISE over here in the corner. So for tonight, if you're going to go out, that time happens to be 10:47 p.m. And to look for it, you want to look for the constellation Lynx. That's where the comet is right now. You can find it because it looks like a giant zigzag across the nighttime sky. And as we go on through the days in the month, it'll start to go towards the Big Dipper, so Ursa Major. But I find it really useful to use the two stars in the bottom of the cup of the Big Dipper to help me guide myself to find where the comet is. It's almost like if you drew a line down and then went a little bit to the left, there the comet would be.
Awesome. Yeah, and of course, anyone out there on YouTube watching right now, if you'd like to get in, ask us some questions about the comet before we get into the moon, we can take this time to answer them. Yeah, I find this really fascinating. We talked a little bit about comets and like the two tails, and I think another really interesting perspective is when you're looking at the comet and you see that beautiful tail. I think a lot of people sort of like have this perhaps cartoon image in their head of like a comet streaking across the sky, but that's really not what's happening, because that tail is actually leading the comet away from the sun, right?
Exactly, yeah. So that tail is a dust tail, and it points away because it's actually radiation pressure from the sun. So photons coming from the sun actually imparting momentum and pushing the dust behind the comet.
And I noticed that you had mentioned in a couple of your interviews, because you've been certainly getting lots of questions from the public about the comet. You had talked about the two different tails. Maybe describe to us what those two different tails are.
Sure. So the tail that you'd be seeing would be the dust tail. So it's kind of that feathery white tail that you see trailing behind. But there's also a smaller blue tail that actually points in a different direction. And that's the ion tail. And the reason why they point in different directions is because the sun affects them in different ways. So like I said, the dust tail is affected by photons coming from the sun. We call that radiation pressure. But the ion tail is affected by solar wind. And so if you've seen a few pictures of the comet, those with the astrophotography skills that I don't have and have that long long exposure camera, you can actually see the blue tail a little bit to the left of the feathery dust tail.
Yeah. And from my experience as well, I don't own a pair of binoculars, but from what I've heard, if you have that long lens in your camera or a pair of binoculars, those are probably the best. I didn't try to look at it through a telescope, but I heard some people that had, and you do get a close-up look maybe at the nucleus, but I think to really get the beautiful effect of the comet, you want to get that tail too. So maybe not so close up is the view that you want. But we do have some questions coming through. Of course, a friend of our weekly chats, Pride, who came to our event yesterday in Telescope. Hey, Pride. Do our eyes focus more detail the longer we look at an object in the distance? Pride says that she seems to be experiencing this, for example, the phases of Venus. So maybe talk about how our eyes adjust.
Interesting. So we know that we have to dark adapt first of all. So you do want to let yourself, when you do go to a dark sky location, to let your eyes adjust at least 20 to 30 minutes to really be able to pick up small details like the comet's tail. And your eyes have both rod and cone cells. Cone cells are for color, rod cells are for dim light. And so you have more rod cells towards your periphery, which is why I used averted vision to look for the comet tail, but your eyes do get tired. So you want to make sure that you do go to a dark sky location, have that dark adaptation, and use that averted vision.
Right. And another really good tip as well. What sort of happens when I go down to the beach is that there's sort of like people gathering around. They sort of see, oh, you're looking for the comet as well. Another really common mistake is that everyone uses their phones for their sky apps to try to figure out where it is that you're looking. But your phone gives off a bunch of white light, which is exactly not the light that we want, right? So you're talking about, Rachel, is that red light is not going to ruin that dark adaptation.
Exactly. And I actually use an app to help me position myself. And it's called Skyview. And that actually has everything in red and it has altered reality. So what I can do is I can point my phone at the night sky, locate any constellation I want, and help me guide myself to that comet.
Awesome. Another quick question. We're going to just focus here on Comet NEOWISE for a second, then we're going to get into the moon. But we got to talk about the comet. This is what everyone's talking about. So Harry,
once in a lifetime.
I know. Was it 6,800 years or something?
It is. Yep.
So this orbit, that's actually what Harry is talking about. It's the orbit. So maybe talk about sort of like the direction and a little bit about where it's going and who in our solar system.
Sure. So it's traveling on what we call a near parabolic orbit. So you can imagine instead of having a circular orbit, if you cut open that circle and kind of stretched it almost to a straight line, that's what our comet is doing. And that kind of goes to show why we have such a long period before it comes back, because it's traveling on this really extreme path. And so like you said, Michael, that period is 6,800 years. So it's definitely a once in a lifetime thing for us.
And I've seen a few pictures of this as well, in showing the trajectory of the orbit, is that where most of the planets and the asteroids in our solar system are sort of on that ecliptic plane. But this comet is not really in that plane. It's kind of going above the plane. Is that right?
Yeah. And part of the reason for that is because long period comets, the source of that is from the Oort cloud. And the Oort cloud is this hypothetical cloud that surrounds our solar system. And the reason I say hypothetical is because the Oort cloud has a lot of kind of ice, gas, and dust, and it's really diffuse. So the spaces in between all the stuff in that Oort cloud is very big. So light that ends up passing through the Oort cloud actually goes right through, and we need reflected light to be able to see things in space. So that's why it's still this kind of hypothetical region of space, but that's where we think long period comets come from.
Right. So if I bring up my orrery here, we kind of can kind of envision sort of like all the planets are sort of like on this ecliptic plane, all going around the sun. But what you're talking about is this Oort cloud, which is just sort of like surrounds, and it's in every direction. So this comet, whoop, my microphone just fell down there. So this comet is kind of coming from this direction, but comets could come in from all directions as well. Is that right?
Exactly. Yes.
All right.